Kia ora koutou. In this video, I'm going to do the first 3 parts of question 3, which is from the 2021 exam. So these are all problems about the normal distribution. So I'm going to cover off A, B, and C in here, which is these 3 questions here. So the first one is an achieved question, the second one is a merit question, and this third one goes up to excellence. Now then there's part D, which is I really like, but I'm going to do that in a separate video, and I'm going to go pretty slowly in this section. So if you're in our class this year, what you should be doing alongside this is a whole bunch of revision from the Walker workbook. It's been quite a long time since we did the probability work, and especially the normal distribution work. I'm going to do this showing you how to do this both using your calculator and using the tables. Now I haven't got a graphics calculator emulator with me on my home laptop, so I'm just going to talk you through what commands to use. Right, so in question 1, we've got a cafe manager who notices that the amount of time a customer waits to receive their takeaway coffee varies. He collects some data over a week and he finds that the mean time waited is 7 minutes with an estimated standard deviation of 1.5 minutes. So we should know straight away that the 2 parameters that we need to model a normal distribution problem are the mean, mu, which is 7, and the standard deviation here, which is 1.5. And those 2 things let me draw the shape of the waiting times for coffee. Okay, so we're told assume that a normal distribution can be used to model the waiting time for a takeaway coffee at this cafe. First, we have to find the probability that a customer receives their coffee within 5 minutes. Now, once you get good at this, this is a really, really quick problem on your graphics calculator, but I think it's well worth drawing a diagram anyway. So here's the situation with the coffee. We'll call the coffee X. And the mean waiting time is 7. And the standard deviation is 1.5. Now, you can't see this directly on the graph, but it's telling you how stretched out that normal distribution is, right? So if it's got a small standard deviation, it might look like that. If it's got, suppose it had mu is equal to 7, and it had a standard deviation of only 0.5, then what we'd have would be a curve that looks much skinnier and taller, but it would have the same bell shape. Okay, so that's the first thing to notice. The next thing to do is to shade in the probability that we want and to write a probability statement. So the P bracket X is less than or equal to 5. Now it doesn't matter if we write is less than or equal to or is less than 5, because we're dealing with a continuous distribution, right? We're looking at the time that we wait for, and that's a continuous variable. What I do want to do though is to colour in the area that I'm looking for on the graph. So just put 5 on somewhere below 7 and colour in that area. Now that tells me that my answer is going to be less than 0.5. Okay, so if we do this on the calculator, all we have to do are the following steps. So we go to stat, and then we go to dist for distribution, and we go to norm for normal. Then the button that we want is NCD. So the C in here stands for cumulative, right, meaning the area up to this value. Then we have to pop in a few bits of information. So we've got lower and upper. That refers to the numbers that we want on here. So my lower in this case is, well, in theory this goes on forever, but actually it would be fine to put 0. 0 is so far away from 7 that there's going to be basically no area out there anyway. So I'm going to put lower is 0 and upper is 5, and then mu is 7, sigma is 1.5, and then we hit XE. And that will find me that probability, and we get 0.0912. Okay, so that's cool if we've got our graphics calculator, but we're going to need to understand how to solve problems using the tables later on anyway, so we might as well practice on this easy one. When we solve any normal distribution problem, we're starting off with the thing, right, X, which has an average of 7, and it's got a standard deviation of 1.5. But what we're going to use to work these probabilities out is this table, which is for Z. Now, Z is the standard normal random variable, and that has a mean of 0, and it has a standard deviation of 1. So we're taking my picture about the coffee, and we're turning it into a Z problem. And then we're going to use these tabulated values to find the probability. So going back to what we've got here, here's my picture of X centered on 7. And now underneath it, I've got a picture of Z, which is centered on 0, and it's got a standard deviation of 1. This one's got a standard deviation of 1.5. So somehow we have to get from the X to the Z. And we do it like this. The first thing that we do is that we shift the distribution back by 7, and then we scale it so that it now has a smaller standard deviation. We don't think about this once we get doing it, but here's what we're doing. We want the probability that X is less than or equal to 5. So that's on here. That number's 5. We're trying to work out what the equivalent number to the 5 is here. So the probability that X is less than or equal to 5 is equal to this. I'm going to do the same thing to both sides of the equation. I'm going to take away 7, and then I'm going to divide by the standard deviation. And that means that this thing here is now my standard normal random variable, and it's equal to -2 over 1.5, right? Which I can write as the probability that Z is less than or equal to -1.333. And this is where hopefully it starts to make some sense again. Okay, because I think for most students, all of this calculation is quite hard to follow. But what we're saying when we get down to here is that when we looked at my first picture, where I had 5 here, we were saying that 5 is 1.333 standard deviations below 7, right? And that's what we're interested in, is how many standard deviations away is my number, is my giraffe height or my coffee weight or whatever. Okay, so now we've got this far, we're going to go to our tables, and we're going to use the tables to find this probability. So the tables they don't give me this probability or this one, they give me this one here. So I have to do some mucking around to make my problem fit this problem. I'm going to go to my tables in here, and I'm going to look up 1.33, which gives me this number, and then here's my little add-on over here. So this is a revision video, so I might be doing that a little bit faster than you want, but I'm going to take this number and I'm going to add on 5. So we'll go back to here. So this is going to equal 0.5 take away 0.4087. So this has come out of my Z table. My Z table is where I look up this probability, and I get this number here, right? So this number here, one more time, is 0.4087. And that means that by symmetry, this number here must also be 0.4087. And the bit that I want is this orange bit in here. And this has to be equal to 0.5 minus 0.4087. So that equals 0.0913. Now I've done that really slowly, but that's because this is the first time we've done this in ages. So hopefully this will get quite fast again. Right, but most of you are going to do this using your graphics calculator and just banging it into the calculator and getting out this directly, right, using upper and lower and so on. Okay, so that's the first part done. Now the second part, hopefully I'll go a little bit faster, is where the cafe has got 150 customers who order takeaway coffee after the afternoon period. How many of these would you expect to have to wait for between 8 and 10 minutes for their takeaway coffee? So step 1 is to find the probability that the coffee waiting time is between 8 and 10. And step 2 is to multiply this by 150. And if we do that, it turns out, and we round that sensibly, that's going to be a merit question. So I want you to pause the video and try and do this one straight into your graphics calculator, using lower of 8, upper of 10, mu of 7, and sigma of 1.5. So if we do all of that, do the same steps as above, and hit Exe, and we get our answer, which is 0.2297. So step 2 is to take 0.2297 and multiply it by 150, because we're saying about 23% of the customers can expect to wait for between 8 and 10 minutes. So that's going to give me 34.455 customers. Don't leave it like that. Just make sure, well, do leave it like that to start with, and then round it sensibly. Let's put that back in. So I do want to see that number, 34.455. And then we're going to write a sentence in context. So approximately 34 or 35 customers would wait 8 to 10 minutes for their coffee. All right. Okay, I'm just looking at whether I've got time to do part C. Now, I think I do, but I'm going to skip over how to do this using the Z values. Okay, well, I'm just going to do it really, really quickly. Just find some blank space on here. Okay, so if we don't have our graphics calculator and we're using the table, what we're going to do is we'll do standardizing on both sides. So we're going to have P, write 8, take away the mean, divided by 1.5 is less than or equal to Z. 10, take away the mean, divided by 1.5. That gives me P, the probability of Z being between 0.667 and 2. So that's Z, and that's 2. And then we're going to find two separate areas. That's 0.667. And we're going to find the area between 0 and 2. This is using my tables. And we're going to do this one minus this one. And we'll get 0.2295. All right, on to the hard one. Actually, I'm just looking and I'm seeing whether we've got time in this video. I might need to do a separate video, I think. I'm going to read through this now in case anyone's still watching. And we'll just look at what we've got to do. Because in this question, the trickiest thing is working out what they want. So the manager noticed that when a particular staff member was rostered on, 30% of customers waited less than 5 minutes to receive their coffee. So this is one where we're going backwards. The probability that X is less than or equal to 5 is now equal to 0.3. So we can draw that picture because it tells us the mean is still 7 minutes, but now we're getting a big probability here, much bigger than before, of 0.3. And the manager suggests that the staff member should be rewarded for good service. So calculate an estimate of the standard deviation of the time taken to receive a coffee and see if you agree with the manager's suggestion. So we're going to work backwards in this problem to figure out sigma. Okay, so just a preview of how we're going to do that. And we know that Z is equal to X minus mu over sigma. So in my standard normal, I'm going to say what value of Z is going to chop off 0.3 area here, right? Or 30% of the probability in that tail. And we're going to figure out that we can either use inverse normal or invn on my calculator, or I can do it using the tables. And if I do it using the tables, what I'm hunting for this time, I'll just get rid of some of the marks on here, is I'm looking through my table and I know that I've got 0.3 area here. So the number that I'm looking for inside the table to fit the pattern is 0.2 here. Right, so you can see that it's going to be somewhere in here. At 0.52, I'm at 1985. If I add on a bit from over here, I'm nearly there. So it's 0.524 using the table. Going back to using the calculator, I'm going to get negative 0.5244. So just let me go through that a bit more slowly. All right, so here we want to have the lower tail having an area of 0.3. What is this value? And it's going to give me Z equals negative 0.5244.